All right. So yesterday we have seen chapter 2, which was survival analysis, and I tried to explain you the variables, the outcome variable for survival analysis. So unlike linear regression, where there is only single outcome variable, which is continuous, and logistic regression, there is only one outcome variable, which is binary, in general categorical. In case of survival analysis, we expect two outcome variable, time as it is, and indicator as status variable. So whether the event is observed or not is one variable, and the length of time or how long it takes to observe the event of interest is another variable. So in Stata, you have to first declare the data as survival data, so that the system understands what's the time variable and what's the status variable means. Now, then I tried to explain you some examples where to apply survival analysis. I think survival analysis can be applied in almost all health-related fields. It's very commonly used in health and health-related fields like hospital data. Data collected from the hospital are most probably appropriate for survival analysis. Because in our hospital, we do have a number of follow-up data like chronic disease follow-up, HIV/AIDS follow-up, TB follow-up, and any kind of disease are under follow-up. Because we believe treatment works or drug works not at a fraction of a second, but over time. Not at a cross-sectional of time, but in a follow-up or over time. So this kind of structure, data structure, requires survival analysis basically to assess or to generate information. Once we agreed that we do have survival data, then we can analyze this data in different approaches. We can analyze the data using non-parametric approach. You can analyze the data using semi-parametric approach. We can analyze the data using parametric approach. So each of the domains of the model has their own extension as well. The non-parametric one is simple. That includes live table, Kaplan-Meier survival curve, and log rank test. And we have seen the three of them yesterday. The second one is semi-parametric method, and the semi-parametric one is the model, the regression model. So we call it, as the name indicates, semi-parametric. It means the model has both parametric and non-parametric component. So the systematic component is kind of parametric, representing parametric, and the random component is representing the semi-parametric one, because, no, sorry, the non-parametric one. The T by failure indicator, we didn't specify any distribution. So it's distribution free. Whereas on the right-hand side, F of covariate, we assumed a certain distribution, and we call this model semi-parametric. Now, the advantage or the advantage of semi-parametric over the non-parametric one is because we can include as many covariate as possible simultaneously. So we can compute an adjusted hazard ratio, we can compute adjusted hazard ratio, so that we can control possible confounders at analysis stage. So in doing so, before we interpret the results from Cox regression, we have to test the assumptions. All right. So, in fact, the model can be fitted using this formulation like SD Cox. Then you can list all the independent variables You have to make I dot for categorical, but you can leave unspecified for the continuous one. In this model, cat gravida and sex were categorical. That's why we put I dots. Whereas family size and mom age are numeric, so we don't need to put I dots. Now, before we interpret, we have to test the assumptions, PH assumption. The validity of the model output depends on the assumption as well. Before we interpret the results, we have to first check the PH assumption. And checking assumption can be plot. We can use plot to check the assumption. We can also use cumulative sum of martingale residual and Kolmogorov type of Superman test. And the third one is fitting time dependent covariates. And finally, scheduled residual. Field residuals can be used to test the PH assumption. Yesterday, I showed you that it stat test command in Stata to test the model assumption. So significant p-value indicates the violation of assumption. If the assumption is violated, we can remove the variables one by one and check if the assumption again until the assumption is satisfied. So if you want a variable to be included while it violates the assumption, then you have to use extension of models. Now, in summary, the evaluation of the proportional hazard PH assumption in survival analysis is an important issue when hazard ratio is chosen as a summary measure or as a text size. So if we decide to use hazard ratio in proportional hazards model, then we have to test the assumption. Once we identified the variable that violates the assumption, we can use the following extensions: either stratified analysis or time-dependent Fox regression, or probably might be other extended models can be used. Finally, here is an assignment, assignment 1. Consider the child data sets presented in chapter 1. The time variable is serve type, and the status variable is event. So the question is compute the life table with an interval of 30 days. Construct the Kaplan-Meier survival curve for the variable sex of the child and cat gravidity. Use log rank test to check if the difference is significant. Fit Cox regression for the independent variables there, and compute the crude and adjusted hazard ratio. Test the PH assumption of the model. Either of you can use any method to test the assumption. Finally, interpret the results. So this is the final slide for chapter 2. As I mentioned yesterday, I think this is part B, and part B is entirely focused on about longitudinal data analysis. Yesterday, I tried to give you some highlight about the extensions. So far, the models that we have seen so far are basically depending on one of the underlying assumptions, that is independent observation. So we assumed the observations are independent, sorry. All right, sorry for the interruption. መጀመሪያ ግልጽ የሆነ አንደርስታንዲንግ እንዲኖረን ፈልጌ ነው። ለምን ፓርት ቢ ያስፈልገ? ለምን ኤክስቴንሽን አስፈለገ? እስካሁን ያየናቸው ሞዴሎች እነ ሊኒየር ሪግሬሽን እና ኖቫ እና ቲ-ቴስት እነ ሎጂስቲክ ሪግሬሽን እነ ሰርቫይቫል አናሊሲስ እነዚህኑ ለምን አንጠቀምም? ዴታ ሎንጊቱዲናልም ክላስተር ዴታ ቢሆንብንም ቅሉ ግን እስካሁን ያየናቸው ሞዴል ለምን አንጠቀምም የሚል ጥያቄ በሁላችሁም አእምሮ እንዲነሳ ስለፈለኩ ነው። ምንድነው ያልኩት? እስካሁን የተጠቀምናቸው ሞዴሎች በአንድ አሳምፕሽን ላይ ሪላይ ያደረጉ ናቸው። ያ አሳምፕሽንም ኢንዲፔንደንት ኦብዘርቬሽን የሚባለው። እነዚህ እስካሁን ያየናቸው ሞዴሎች የሚሰሩት አንደር ኢንዲፔንደንት አሳምፕሽን። ኦብዘርቬሽንስ አር ኢንዲፔንደንት ማለት የዴታችን ውስጥ ያሉ ኦብዘርቬሽኖች አንዱ ከሌላው ኢንዲፔንደንት ናቸው። ለምሳሌ አሁን ከዚህ ክላስ ውስጥ ያላችሁት 7 ሆነ 8 ሰዎች አላችሁ እና ከናንተ ላይ አሁን ጀስት የሆነ ኤቪደንስ ጀነሬት ማድረግ ፈልጌ ዴታ ኮሌክት ላደርግ ነው። ሶ ሁላችሁም ላይ ከጋዲሴም ከኦልማድ ሚኒስትር ከተመስገን ከሁላችሁ የሚከተሉትን ቫሪያብሎች ወሰድኩ። ላይክ ፊልድ ኦፍ ስተዲ ጠየቅኳችሁ፣ ይር ኦፍ ሰርቪስ፣ ኤምፕሎይመንት ስታተስ፣ ምን ቦታ ነው የምትሰሩት ምናምን ብዙ አይነት ዘን ቢሄቪራል ካራክተሪስቲክሶችንም ትናንት ስለጠይቅ ነበረ። ቫክሲኔትድ ኮቪድ ቫክሲኔት ወስዳችኋል አልወሰዳችሁም? እንደዚህ ሶ I have been asking you a certain question። ያ ማለት ዴታ ነው ጀነሬት ያደረኩት። ይሄንን ዴታ አናላይዝ ማደርግ ከሆነ I assumed these observations are independent። ምክንያቱም የተመስገን ዴታ ከአበራ ዴታ ይለያል ወይም ደግሞ ከሳምራዊት ይለያል። I assumed you are independent። ለምሳሌ have you been vaccinated ብዬ ስጠይቅ አንዳንዶቻችሁ አይ ቫክሲኔትድ አይደለም ወይ አይደለም አልተከተብኩም ወይም ተከትቤያለሁ ምናምን ብላችሁ ትመልሳላችሁ እና at a point in time ስለለካውት አሳምፕሽኑ የዚህ ዴታ አሳምፕሽን ምንድነው? ኢንዲፔንደንት ነው። the observations are independent ስላችሁ የመጡት የወሰድኩት መረጃ ከተለያዩ ሰዎች ነው የወሰድኩት ማለት ነው። so similarly ለምሳሌ እድሜ ብጠይቃችሁ እድሜ ኤጅ how old are you ያልኩ ሁላችሁንም ስጠይቅ 7 ወይም 8 የተለያየ ኤጅ አገኛለሁ ማለት ነው። probably it may be the same ሁለት ሰው 32 ሊሆን ይችላል ወይ 33 doesn't matter but what I make sure is each observation comes from different individual ከተለያየ ሰው ነው የመጣ። ስለዚህ ከተለያዩ ሰዎች የመጣ መረጃ ኢንዲፔንደንት ነው የሚለውን አሳምፕሽን ያሟላልኛል። ከዛ በኋላ based on the outcome of interest ባይናሪ ከሆነ ባይናሪ ሎጂስቲክ፣ ኮንቲኒየስ ከሆነ ለምሳሌ ብለድ ፕሬሸራቸውን ለክቼ ከሆነ ወይም ሴረም ዩሪክ አሲድ ሌቭላቸውን ለክቼ ከሆነ ሊኒየር ሪግሬሽን መጠቀም እችላለሁ ወይም አኖቫ ሌሎችንም መጠቀም እችላለሁ ማለት ነው። ነገር ግን አሁን ዛሬ ይሄን ለክቼ ዛሬ ጠይቂያችሁ እንደገና ደግሞ ነገ እናንተኑ ራሳችሁን መረጃ በወስድ ለምሳሌ ብለድ ፕሬሸር የእናንተን ብለድ ፕሬሸር ዛሬ ለካው ሌሎችንም ቤዝላይን ቫሪያብሎች ለካው ነገ ደግሞ አሁንም ብለድ ፕሬሸር ከነገ በኋላ ብለድ ፕሬሸር ክላስ ከጀመርን አንስቶ የተለያዩ ፋክተሮችን ኦቨርታይም ከለካውኝ እንበልና 7 ከሆናችሁ እናንተ የክላስ ውስጥ ያላችሁ 7 ከሆናችሁ ለ5 ቀን ወይ ለ6 ቀን ለክቼ ከሆነ 7 ሲባዛ በ6 ወደ 42 አካባቢ ሜዠርመንት ወይም ዴታ ፖይንት ይኖረኛል ማለት ነው። ኦብዘርቬሽን ይኖረኛል ማለት ነው። so the issue is this data is not independent አይደለም ዲፔንደንት ነው። ምክንያቱም የዳዊት ለምሳሌ ዳዊት ሰኞ ላይ የወሰድኩት ብለድ ፕሬሸር ለትናንት ማክሰኞ ከወሰድኩት ዛሬ ሮብ ከመወስደው ነገ ሐሙስ የምወስደው ጋር ከዳዊት በመሄዳቸው 5ቱም ሜዠርመንት ወይም 6ቱም ሜዠርመንቶች ኮሬሌት ያደርጋሉ because physiologically he is a single person physiologically ተመሳሳይ ነው። ሌሎችም ከአንድ ሰው የተወሰዱ ናቸው። so ኮሬሌት ያደርጋሉ ማለት ነው። ስለዚህ ኢንዲፔንደንት አሳምፕሽንን አያሟላም። ከኔ የተወሰዱ ከኔ ለምሳሌ እኔ ጋር ተመሳሳይ መረጃዎች ኦቨርታይም ከተወሰደ ከአንድ ግለሰብ በመወሰዱ ኮሬሌት የሚያደርጋቸው ነገር because እድሜ ያው ነው አይቀያየርም ጾታዬ አይቀየርም ብላ ብትሉት ተመሳሳይ የሆኑ የማይቀየሩ አሉ ወራስ የሚቀየሩ ደግሞ ባዮሎጂካል ወይ ነው ባዮማርከሮች ባዮሎጂካል ፋክተሮች ደግሞ ሊለያዩ ይችላሉ so because of the fact that measurements were taken from the same individual the assumption of independence will be violated ስለዚህ longitudinal data ካላችሁ cluster data ካላችሁ እነ linear regression እነ logistic እነ ምናምን አይሰሩ ለምን ከተባላችሁ because the assumption for these models is independent በቃ independent observation ላይ ነው የሚሰሩ ነው የሚለው ምን ይሆናል አሁን ለምሳሌ dependent observation ላይ እነዚህን ሞዴሎች ብንጠቀማቸው ምን ይሆናል ምን ይፈጠራል ካላችሁ the results will be biased ምክንያቱም confidence interval affected ይሆናል p-value affected ይሆናል standard error affected ይሆናል at the end of the day የምታገኙት ቁጥር ትክክለኛ ቁጥር አይሆንም ማለት biased የሆነ ቁጥር ነው ማለት ነው ትክክለኛ ኮንክሉዥን መስጠት አትችሉም ማለት ነው እየሰማችሁኝ ነው
Yes, we are flowing the class.
ሌሎች አይሰሙም ማለት ነው
ማነው እየሰማን ነው ላችሁ
ጥሩ መልካም ግልጽ ሆኖላችኋል ለምን ወደ ትራንዚሽኑ ገብቷችኋል አይደል ወደ ሎጂክ ስለ ሞዴሎቹ ከማውራቴ በፊት ፈርስት ዲፈረንሱን አንደርስታንድ ማድረግ አለብን ለምን አስፈለገን why we need a special model for longitudinal or cluster data የሚለው because the standard models the basic models that we have seen so far in the first part of the chapter they assumed independent observations are independent ብለው ነው assume ያደረጉት ሌሎችም አሳምፕሽኖች እኮ አሉ አሁን ለሊኒየር ሪግሬሽን ፊት ስታደርጉ እንዳያችሁት ኖርማሊቲ አሳምፕሽን ሆሞሴዳስቲሲቲ አሳምፕሽን ሊኒየሪቲ አሳምፕሽን እያላችሁ አይታችኋል ያዘው ይሄኛው ግን ኢንዲፔንደንት አሳምፕሽን ግን ለነዛ ሞዴሎች ብቻ የተቀመጠ ነው ማለት ነው ኦኬ ሶ ናው አይ ቲንክ እንግዲህ በዚህ መልኩ ከተረዳዳን ወደሚቀጥለው ሄዳለሁ ማለት ነው ለቻፕተር 3 let's start first longitudinal data so yesterday in statement አውርቼላችሁ ነው ያልኩት a longitudinal study refers to an investigation where participants or patients outcome are possibly treatments or exposures are collected at multiple follow-up time over time ነው የተለካ ማለት ነው ስለዚህ አንድ ሰው አንድ ግለሰብ አንድ ስተዲ ፓርቲሲፓንት ከአንድ በላይ ሜዠርመንት ይኖረዋል ማለት ስለዚህ እነዛ ከአንድ በላይ የሆኑ ሜዠርመንቶች ከአንድ ሰው በመሄዳቸው ኮሪሌትድ ናቸው ማለት so repeated measurements or data or cluster data are assumed to be correlated ለምሳሌ መቼ ነው ዩኒትስ ካን ኮሪሌትድ የሚሆኑበት ወይ ክላስተር ዴታ የምንለው ምንድነው ለምሳሌ ዩኒትስ could be ለምሳሌ subject study sub patient ሊሆኑ ይችላል ፓርቲሲፓንት ልንላቸው ይችላል እነዚህን ኦቨር ታይም ከለካናቸው ከነዚህ ከሳብጀክት በሉት ፔሸንት በሉት ፓርቲሲፓንት በሉት የተለያየ ሜዠርመንት ታገኛላችሁ ማለት ነው ኦቨር ታይም or animal ሊሆን ይችላል animals can be followed or plants can be followed doesn't matter all right the other one is clusters might be also cluster ሊኖረን ይችላል family like towns correlation ቅድም ያልኳችሁ የኮሬሌሽን እንደው ጠር አድርጎ ለመነጋገር ያህል ያላችሁ ከጃችሁ ላይ ያለ ዴታ ኮሬሌትድ የሚሆንባቸው ሶስት ምክንያቶች አሉ አንድም ዴታው ሎንጊቱዲናል ከሆነ ኦቨር ታይም ከለካችሁት ሁለተኛው ደግሞ ክላስተር ዴታ ከሆነ ክላስተርስ ላይ ከሆነ ለምሳሌ ትምህርት ቤቶች ሆስፒታል ጤና ጣቢያ ቀበሌ ጎጥ ዲስትሪክት እዚህ ላይ የሚሄዱ ዴታዎች ኮሪሌትድ ይሆናሉ እንበልና አሁን እናንተ አሁን ሐረር ላይ you may want to conduct a study among school children ትምህርት ቤት ላይ ካሉ ህፃናት ላይ ጥናት ማጥናት ፈልጋችሁ ዴታውን የምትወስዱት at a point of time ነው ፎሎ አታረጓቸው ፎሎ አፕ የለው just simply at a point in time ነው የምትወስዱት ነገር ግን ስኩል ችልድረን ስላላችሁ ሀረር ላይ ያሉ የተለያዩ ትምህርት ቤቶች ኤሌመንታሪ ትምህርት ቤቶች ይኖራሉ ምን በልና አሁን ስፔሲፊክ እናርገውና ይሄን ሳብጀክት we want to study the nutritional status of children under let us say 5 or under 10 ሊሆን ይችላል እና መዋለ ህፃናቶችን ነው ኮንሲደር ማድረግ የፈለጋችሁ መዋለ ህፃናት ላይ ህፃናቶችን ወስደን ክብደታቸውን ኦቨርዌት ኦቤሲቲ ምናምን አለ የሚለው ነገር ለማጥናት ፈለጋችሁ ስለዚህ ሀረር ላይ እንበልና ኦኬ ካለስ ጥሩ ምን ይኖራል ብዬ ልገምትና ወደ 30 መዋለ ህፃናት አሉ ካላችሁ ወይም ደግሞ 50 እናርጋችሁ 50 መዋለ ህፃናት አሉ ካላችሁ እነዚህ 50ዎቹን እንግዲህ ሳምፕሊንግ ምናምን ቴክኒኮች ተጠቅመን ከ50ዎችም ወይም ደግሞ ወደ 30 ቀንሳችሁ ከእያንዳንዱ መዋለ ህፃናት ተማሪዎችን ልትወስዱ ነው የመዋለ ህፃናት ተማሪዎችን እንበልና የታሰይ መዋለ ህፃናት 1 በቁጥር 1 2 3 እያላችሁ በቁጥር ብትሰጧቸው ከአንድ ላይ 30 ተማሪ ወስዳለሁ ካላችሁ from kindergarten 1 30 ስቱደንት ወስዳለሁ then from kindergarten 2 ይሄን ያህል ወስዳለሁ ካላችሁ እነዚህ 30 ተማሪዎች ከመጀመሪያው መዋለ ህፃናት የምትወስዷቸው ከአንድ መዋለ ህፃናት በመምጣታቸው ኮሪሌተር ናቸው the 30 students coming from the same school they are assumed to be correlated ለምን ብትሉ because ያ ትምህርት ቤት የሚያስተምሩት አስተማሪዎች አንድ አይነት ናቸው የሚያገኙ ፋሲሊቲ አንድ አይነት ነው የውሃ የምናምን እንደዚህ አይነት ፋሲሊቲዎች ካሉ አንድ ተመሳሳይ ነው ሼር የሚያደርጉት the same thing the same facility will be shared among the 30 students so these 30 students are correlated because they are from the same school ወደ ፔሸንት እንወሰደው ለምሳሌ ወደ ኛውን ደግሞ ኤግዛምፕል ፔሸንት ላይ ለማጥናት ፈልጉ ወይም ዲኤም ፔሸንት ላይ ወይም ደግሞ ሃይፐርቴንሲቭ ወይ ኤችአይቪ ፔሸንት ላይ ለማጥናት ፈልጋችሁ ሀረር ላይ የተለያዩ ጤና ተቋማትን ከጥራታችሁ ኢንክሉድ ካረጋችሁ patients coming from the same hospital or the same health center they are assumed to be correlated ለምን ካላችሁ because they are going to be treated by the same physician by the same nurse or by the same in general health professional at the same time they are going to get access the same facility ለምሳሌ የመለኪያ የሆነ ኢኩዊፕመንት ሜዲካል ኢኩዊፕመንቱ አንዱ ጤና ጣቢያ የተሻለ ከሆነ all the patients from that health facility will access those equipments in the same way ስለዚህ እንደዛ በመሆናቸው ኮሪሌትድ ይሆናል so ምን ልላችሁ ፈልጌ ነው it's not only longitudinal data that resulted correlated data result የሚያደርግ longitudinal ስለሆነ ብቻ አይደለም ዴታችሁ ክላስተር ከሆነም it leads to correlated data ሁለቱን ነገርኳችሁ ማለት ነው longitudinal ከሆነ ዴታችሁ ክላስተር ከሆነ at the end of the day correlated ይሆናሉ ብያችኋለሁ what is the third one ሶስተኛው repeated measure ከሆነ ነው repeated measure longitudinal ጋር ሊመሳሰልባችሁ ይችላል ግን እኔ ሪፈረንት ወይ ነው repeated ማለት ከአንድ ሰው ከተለያየ ቦታ ከወሰዳችሁ ለምሳሌ repeated the same time but repeated measurement ይሄን እንደምሳሌ የሚወስዱት ለምሳሌ ራት ወይም ደግሞ የአይጥ ጥናቶች ሲጠኑ ከተለያየ የብሬን ፓርታቸው at the same time but from the different part of their brain data ይወሰዳል on the right part of their brain on the left on the top ተለያየ ፓርት ላይ ይወሰዳል ስለዚህ ምንም እንኳን ከተለያየ ቦታ ብትወስዱትም ዴታው ኮሪሌትድ ይሆናል ምክንያቱም ከአንድ ሳብጀክት ስለተወሰደ ማለት from the same subject at different position or location at the same time ከሆነም ኮሪሌትድ ይሆናል ያን ዴታ ነው ሪፒትድ የምንለውና ምን ለማጠቃለል ያህል ዴታ might be correlated due to 1 longitudinal nature of the data 2 cluster nature of the data 3 repeated nature of the data now such data or such repeated measures data are correlated within the subject and thus requires special statistical techniques for valid analysis and inference ያ ነው ኮሪሌትድ ናቸው እነዚህ ዴታዎች ሪፒትድ ከሆኑ ክላስተር ከሆኑ ሎንጊቱዲናል ከሆኑ ኮሪሌትድ ናቸው ይሄ ኮሪሌትድ ዴታ ደግሞ ስፔሻል አቴንሽን ያስፈልገዋል ለምን ካላችሁ because there is different there is a kind of correlation among the observation All right, so let me proceed to the next slide. Now, when we say longitudinal data, it resulted a hierarchical nature or hierarchical type of data structure. So the observations have a multi-level structure, like some patient I from facility K followed over time T. You see, you have I stands from the patient, K stands from, might be from facility or institution, and T stands from time. This can be represented as K, can run from 1 to K, 1, 2, 3, 4. Previously, I was talking about the school, I was talking about health facility. So you may include in your data K number of facility or K number of hospital or school. I runs from 1 to N, where N is a sample size. I represents the subject, the study participant. 1, 2, 3, N. If your sample size is 300, for instance, N will be 300. Whereas T is time. Time also 1, 2, 3, T. Where T is capital T is the maximum follow-up period. So you may follow the patients for about a month or a year or a couple of years. So T stands from the time at which the study participants were followed. So T1 means the time at which the measurement one was selected. T2 means the time at which measurement 2 was selected, measurement 2 was taken. 3 means time 3 at which the third measurement was taken. So it goes like this up to T, up to capital T. So if you follow the patient, if you took 10 measurements, the capital T will be 10. If you took 5 measurements, then capital T will be 5. The time at which the fifth measurement were taken. So there are a lot of examples on this type of data structure. If you consider, for example, the RT clinic, HIV infected individuals were followed for over time since they were diagnosed for HIV. So every time, might be monthly or every 6 months or 2 months, according to their visit, CD4 count will be taken, viral load will be taken, and other clinical variables might be taken from the same subject at different time. X number of measurements will be taken. So whereas when we say multi-level or when we say cluster data, as you can see from the plot or from the slide, we have different levels. Level 1, population. Level 2, region. Level 3, neighborhood. Level 4, family. Finally, person. So we are interested to take measurement from an individual. However, the individuals are within the family. The families are within the neighborhood. The neighborhoods are within the region, and the region are within the country. So the health outcome of the individual might be affected by the household characteristics. The household characteristics might be affected by the neighborhood characteristics. Neighborhood characteristics might be affected by the region characteristics, and so on. So if you want to analyze the data from the subject, you have to take into account the characteristics of the household, the characteristics of the neighborhood, and the characteristics of the region. So the point here is, it's not only the individual variable, individual level variable, which affects the health status of that individual. Rather, it's also family level variables affect also the individual outcome. እንደዛ ነው የሚሆነው። ለምሳሌ የህፃኑን እዚህ ጋር የምታዩት ህፃን ናት። ይቺ ህፃን ከዚህ ቤተሰብ ነው የወጣችው። ይሄ ቤተሰብ ከዚህ ኔበርሁድ ነው የወጣው። ስለዚህ የህፃኗ ሌታሳይ ኒውትሪሽን ስታተስ በፋሚሊ ኢንካም ይወሰናል። የፋሚሊ ኢንካም በኔበርሁድ ኮንዲሽን ይወሰናል። and so on ያለ ሄዳል እንበልና የዚች ህፃን ቤተሰቦች የተማሩ ከሆኑ ኢምፕሎይድ ከሆኑና የተሻለ ደሞዝ የሚያገኙ ከሆነ ሌላም መጥቀስ እንችላለን። የህፃኗ ሄልዝ ስታተስ በእነሱ በቤተሰብ ካራክተሪስቲክስ ይወሰናል ማለት ነው። ሌላው እነዚህ ቤተሰቦች ደግሞ የሚኖሩበት ማህበረሰብ አካባቢ ለምሳሌ የሚኖሩበት ኔበርሁድ የጥሩ ሆስፒታል ካለ ጥሩ ትምህርት ቤት ካለ ሌላም መጥቀስ ይችላል። ኔበርሁድ ካራክተሪስቲክስ የተሻለ ማኔጅሜንት ካለ የፋሚሊ ኮንዲሽኑ ይወሰናል ማለት ነው። So you have to take this one. And this type of data structure is known as multi-level data structure. Multi-level. Level 1, level 2, level 3. This is level 1. Level 1 variables are individual level variable. Level 2 variables are household level variable. Level 3 variables are neighborhood level variables. እያለ ይቀጥላል ማለት ነው። So ወደኛ ኮንቴክስት እናመጣው ለምሳሌ ኢዲኤችኤስ ኢትዮጵያን ዲሞግራፊክ ኤንድ ሄልዝ ሰርቬይን ስትወስዱ it's a kind of multi-level. two stage ነው ግን multi-level kind ነው። የኢዲኤችኤስ ዴታውን ስታስቡ መረጃው የሚሰበሰበው ከግለሰቦች ነው። ነገር ግን እነዛ ግለሰቦች የሚመረጡት ከሆነ ክላስተር ነው። ያ ክላስተር የሚመጣው ከሪጅን ነው። ሪጅኑ ደግሞ ከሀገሪቱ ኢትዮጵያ as a nation is divided into different regions and the regions again divide into zones and the zones again divide into district or ወረዳ is divided into ቀበሌ divide into probably might be ጎጥ ሊኖር ይችላል and then ጎጥ is divided to household. Then after the household individuals can be assessed ማለት ነው. Individuals can be interviewed. Now you can see these are kind of multi-level or two-level data structure ነው የሚሆነው። የኢዲኤችኤስ two-level እንዲኖር አድርገው ነው የሰሩት። ስለዚህ anyone who wants to analyze data class ማነው እሱ ኢዲኤችኤስ ዴታን አናላይዝ ማድረግ የፈለገ ሰው he or she should account the correlation እንጂ ኢዲኤችኤስ ተጠቀምኩ ብላችሁ ሎጂስቲክ ሰራው ምናምን ብትሉት acceptable አይደለም። because EDHS data by nature is correlated. It's because it's a cluster type of data. Is that okay?
Yes.
All right. ዳዊት አንገቱን ሲነቀንቅ ይታየኛል። ሌላው ሰው ግን አንገትም ራስም ምናምን ስለሌለ ማየት አልቻልኩም። All right. Okay. So going to cluster data, as I already mentioned, ገልጬላችኋለሁ። A good example is EDHS ብያችኋለሁ። EDHS is a good example of cluster data. So an outcome is measured once for each subject, and subjects belonging to or nested into a cluster, such as family, school, or neighborhood, they are assumed to be correlated. The cluster የምንለው ፋሚሊ ሊሆን ይችላል፣ ስኩል ሊሆን ይችላል፣ ቅድም እንዳልኳችሁ ጤና ተቋም ሊሆኑ ይችላሉ። And there are different structures to be a cluster. So the number of subjects in each cluster may vary from cluster to cluster. I think I already mentioned አዳመጣችሁኝ። ቅድም የሰጠኋቸው የመጀመሪያ ሁለት ኤግዛምፕሎች የትምህርት ቤቱና የኪንደርጋርተኑና የመዋዕለ ሕፃናቱና የነሱ ናቸው። So outcomes measured from the numbers of these groups are likely to be correlated. So students from the same school assumed to be correlated. ለምን ካላችሁ because there are many more things they share in common. They share the toilet commonly, they share the teachers, they share any facility in the school because of the fact that they share some facilities. The data observed from these individuals are assumed to be correlated. So when you come to two-level data structure ወይም ደግሞ cluster data ስታዩት እንደዚህ ነው የሚመስለው። ለምሳሌ ስኩል አለ፣ ስኩል 1፣ ስኩል 2፣ ስኩል 3። Schools are level 2 variable. From each school there are students, student 1, student 2, student 3. So student 1, student 2, student 3 are from school 1. Since they are from school 1, they are correlated. I mean their measurements እነሱ ሳይሆን ኮሬሌት ናቸው የምላቸው ሜጀርመንቱ ነው እያወራሁ ያለው። The data collected from the students from the same school are assumed to be correlated. School 2 ላይ ደግሞ student 1, student 2, student 3 እያለ ይችላል። So since these students are coming from this school, we assume the data collected from these students are correlated. So this variables at student level variables are known as level 1 variable. The school level variables are known as level 2 variable. ለምሳሌ ትምህርት ቤቱ ሽንት ቤት አለው ወይ አስተማሪዎቹ ምናምን ብላችሁ ብትጠይቁ level 2 variable እንበልና accessibility of toilet ብዬ ብትጠይቅ ትምህርት ቤቱ ጽዱ የሆነ ሽንት ቤት አለው ብዬ ስጠይቅ yes ከሆነ ለነዚህ ተማሪዎች ሁሉም yes ነው የሚሆነው all students who are from school 2 will say yes ምክንያቱም ይሄ ቫሪ የሚያደርገው ትምህርት ቤት ስለሆነ ማለት so those variables are known as level 2 variable እነዚህ level 2 variable ከዚህ ጋር ቫሪ ያደርጉ ማለት ነው እዚህ ጋር yes ከሆነ ሁሉም yes ነው የሚሆነው እንበልና እዚህ ትምህርት ቤት ላይ ስኩል ፊዲንግ ጀምራችኋል ትምህርት ቤት ምገባ ጀምራችኋል ወይ ብለን ትምህርት ቤቱ yes ካለ ተማሪው ነው የሚልበት ምክንያት የለም ምክንያቱም ትምህርት ቤቱ ጀምሯል ስለዚህ ይሄ ቫሪያብል ተማሪዎቹ ላይ ቫሪ ያደርጉ ኮንስታንት ፊክስድ ይሄ ትምህርት ቤት ስኩል ፊዲንግ ጀምሯል ወይ በየጠይቀ ይሄ ትምህርት ቤት yes ብሎ ይሄ ትምህርት ቤት ግን ኖ ሊል ይችላል if this school says no then all the students under the school will say no constant ነው ቫሪ ያደርግ በቀደም ቫሪያብል ዲፋይን ሳደርግላችሁ a variable is a characteristic which varies ብያችኋል which vary among the study participant ብያችኋል among the study participant ቫሪ የሚያደርግ ከሆነ ቫሪያብል አይደለም ቫሪያብል ያልንበት ምክንያት ቫሪ ስለሚያደርግ አሁን ከናንተ ውስጥ እድሜ ብጠይቅ how old are you ብጠይቅ age is a variable ምናልባት አሁን current resident ብጠይቅ what's your current resident እናንተን አሁን current resident ብጠይቃችሁ ቫሪያብል አይደለም አስፋራስ አይነው ሁላችሁም ሐረር ከሆናችሁ ከተማ ነው የምትሉት ስለዚህ it doesn't vary it's a constant variable አይሆንም ማለት ነው residents of students of this batch ብጠይቅ it doesn't vary variable አይደለም እሺ okay so when you come to the data structure for cluster data looks like this example EDHS 2016 data ነው ወሰድኩትና አይታችሁ ከሆነ አሁን እዚህ ሆስፒታል አለ MRI ነምበር አለ ሲቲ ምናምን ነገር አለ ፔሸንት አለ ሴክስ ኦፍ ዘ ቻይልድ ብትወስዱ ኤጅ ብትወስዱ ቫሪ ያደርጋል ኤዱኬሽን ቫሪ ያደርጋል ሪሊጅን ቫሪ ያደርጋል otherwise ቫሪ የማያደርጉ ደግሞ አሉ ማለት ነው longitudinal data ስንል ደግሞ an outcome is measured for the same person repeatedly over a period of time so different subjects may have different number of observation which may be taken as different time point observations made on the same person are likely to be correlated now የዲኤም ፔሸንቶችን ብትወስዱ አሁን በእያንዳንዱ ሆስፒታል ፎሎ አፕ አላቸው ለምሳሌ በየወሩ ከሆነ ሆስፒታል ቪዚታቸው የዛሬ ወር መጥተው የሰጡት ሜጀርመንት አለ ዛሬ ይመጣሉ የዛሬ ወር የሚቀጥለው ወር ሲመጡ እነዚህ ከሴም ፔሸንት የሚወሰዱ ክሊኒካል ቫሪያብሎች ኮሪሌትድ ይሆናሉ ማለት ነው ኤግዛምፕል ቻይልድ ለምሳሌ ህፃናት ቢኖሩ እቹ ቻይልድ 1 ቻይልድ 2 ያላችሁ ቻይልድ ሌቭል ሌቭል 2 ቫሪያብል ነው ይሄ so measurement ለምሳሌ from child 1 measurement 1 at time 1 measurement 2 at time 2 measurement 3 at time 3 ከወሰዳችሁ the measurements taken from the same child are assumed to be correlated እዚህ ጋር second child ላይ ደግሞ measurement first measurement at time 1 from child 2 second measurement at time 2 from child 2 and so on so this is an example of longitudinal data data structure for longitudinal data and the data structure for longitudinal data is in its long form is this one አይታችሁ ከሆነ patient id አለ አሁን patient id and እያለ እስከ 7 ይቀጥላል አይቀየርም sex of the child አይቀየርም ፕሌስ ምናምን ይልና ኤጃቸው ነው ፔሪድ ታይም አለ። ለምሳሌ መጀመሪያ ቪዚት ላይ 0 2 4 6 8 10 12 ያል ታይሙ ነው የሚቀያየረው። So at the first visit the weight of the newborn was 3.3 kilogram. At the second visit it was 5 kilogram. At the third visit it was 6 kilogram. ወይም ደግሞ ሁለተኛው ወር ላይ ወደ 5 አደገ፣ አራተኛው ወር ላይ 6 ሆነ፣ ስድስተኛው ወር ላይ 6.5፣ ስምንተኛው ወር ላይ 6.2፣ አስረኛው ወር ላይ 6.5 መሰለኝ። ዘን ፋይናሊ 12ኛው ወር ላይ በአመቱ 7.3 ሆነ ማለት ነው። ጾታው ሴት አይ ቲንክ ይችላል ጾታዋ ሴት ነው። ስትወለድ የነበራት ክብደት 3.3 ነው። በአመቱ ግን ልክ a year after she was turned to be 7.3 kilogram. So the 7 measurements are taken from the same subject, from the same child. Second 2 የሚለው የሁለተኛው ህፃን ነው ማለት ነው። 3 ሲል ያለ ይቀጥላል ማለት ነው። And this is longitudinal data structure. So analysis ስንሰራ ኢንዲቪጁዋል ፕሮፋይሎች አሉ። እዚህ ላይ እንደምታዩት አሁን ይሄ ኤግዛምፕል የሲዲ4 ካውንት ነው እና these are ላይኖችን የምታዩቸው አሁን ሲዲ4 ካውንት ኦቨር ታይም from HIV infected individual ታይም ኦን ART ኤክስ አክሲሱ ታይም ኦን ART ነው። ዋይ አክሲሱ ደግሞ ሎግ ትራንስፎርምድ ሲዲ4 ካውንት ነው። these plots are I think from my paper የፒኤችዲ ከሰራሁት ፔፐር ላይ ያመጣሁት ናት። ሎንጊቱዲናል ዴታ ስትራክቸር ለማሳየት ነው። ፔፐሩን ታገኙታላችሁ ማለት ነው ፐብሊሽድ። ሶ ኢንዲቪጁዋል ፕሮፋይል ይሄን ይመስላል። አሁን እነዚህ የምታዩቸው 1 2 3 4 5 የአምስት ራንደምሊ የተመረጡ የአምስት ፔሸንቶች ሲዲ4 ካውንት ነው ኦቨር ታይም። ይሄኛው ደግሞ ይሄ በጣም ግራ የምታዩት የብዙዎች ወደ 2550 ሳምፕል ነበረኝና የሱ ነው። ብሉ የምታዩት የሰማያዊ ከለሩ አቨሬጅ ነው። ኦን አቨሬጅ አቨሬጁን ስስለው ይሄን ይመስላል። so this is how you explore ይሄን እንደምሳሌ ነው። ይሄንኛው እንደዚህ ኔቨር አፒን ብቻ የወሰዱትን ለማየት ተሞክሯል። ይሄኛው ኤግዛምፕል ደግሞ ሄሞግሎቢን ነው። y axis is hemoglobin, x axis is time in days. These patients are visceral leishmania ቬል ፔሸንቶች ናቸው እና ቀያዮቹ ሪላፕስ የገጠማቸው ናቸው እና ይሄ አሁን ላይኖቹ የምታዩቸው ሄሞግሎቢናቸው ነው። የሄሞግሎቢን ሌቭላቸው መጀመሪያ ይሄ እዚህ ላይ 0 ላይ የምታዩት ቤዝ ላይ ገና ጥናቱ ላይ ሲገቡ የነበራቸው ግን ኦቨር ታይም እንዴት እንደሆነ የሚያሳይ ነው። ይሄ ሎግ ትራንስፎርምድ WBC ስንስለው ነው እና እዚህ ጋር ለምን ይሄን አስመጣው ካላችሁኝ እንዴት ሎንጊቱዲናል ዴታ እንዴት ቪዥዋላይዝ ልናደርገው እንደምንችለው ዴታ ቪዥዋላይዜሽኑ ነው ይሄ። ኦኬ ናው ስለ ሞዴሊንግ እናውራ። እንግዲህ እንደዛ ከሆነ once we understand the data structure, the data type and the source of correlation, now we can talk about modeling correlated data. I hope all of you understand what correlated data now. Correlated data ምን እንደሆነ አሁን ሁላችሁም ገብታችኋል ብዬ እገምታለሁ። ራይት ተመስገን። ቢያንስ አንገት ክናት ነቀንቅም ድምጽ እንኳን ባትናገር። ኦኬ ኦራይት ይሄ ነው ኮሪሌትድ ዴታ። ብዙ ጊዜ ሎንጊቱዲናል ዴታ ምናምን አካብደን የምናየው ይሄ ነው። ዋናው ኮንሴፕቱ ይሄ ነው። the concept modeling correlated data now. So ignoring the correlation among the observation will badly affect the standard error. ደግሞ ስለ ሞዴሊንግ ስናወራ ይሄን ያየነውን ኮሪሌትድ ኢግኖር ካረግነ ስታንዳርድ ኤረሩን በጣም ይጎዳዋል። This further will affect the estimation of the confidence interval as well as the p-value, which will later affect the decision of the test. ስለዚህ ስታንዳርድ ኤረሩ አፌክትድ ከሆነ ኮንፊደንስ ኢንተርቫሉን እና ፒ-ቫልዩን አፌክት የሚያደርገው ከሆነ ፋይናሊ ዲሲሽናችንን አፌክት ያደርገዋል ማለት ነው። Thus we have to account the correlation in our analysis in order not to make biased decision. So coming to the modeling እንግዲህ ሰምታችሁ ከሆነ ሚክስድ ኢፌክት ሞዴል የሚባል ሞዴል አለ። ባለፈው ቻፕተር 1 ላይም ነካ ለማድረግ ሞክሬያለሁ። A mixed effect model for longitudinal or cluster data can be obtained from the corresponding model for cross-sectional data by introducing random effect. Especially, we have linear mixed effect model, which can be obtained from linear regression. ስለዚህ ዋናው ቁም ነገሩ እስካሁን ያየናቸው ሞዴሎች ኤክስቴንድድ ይሆናል። ሊኒየር ሪግሬሽን ወደ ሊኒየር ሚክስድ ኢፌክት ሞዴል ይመጣል። ሎጂስቲክ ሪግሬሽን እና እነሱ ደግሞ የነሱ ኤክስቴንሽን ጂኤልኤም ነበር የሚባለው ወደ ጂኤልኤምኤም ይመጣል። generalized linear mixed model which can be obtained from GLM, generalized linear model, by introducing random effect. ስለዚህ በባለፈው ነግሬያችኋለሁ። ጂኤልኤም የምንላቸው አንደኛው ሎጂስቲክ ሪግሬሽን ጂኤልኤም ነው የሚባለው generalized linear model እና ኦርዲናል ሎጂስቲክ ሪግሬሽን ሁሉ ጂኤልኤሞች ናቸው። መልቲኖሚያል ብታረጉት ጂኤልኤም ነው። ስለዚህ ጂኤልኤም ራንደም ኢፌክት ስናስገባበት ወደ ጂኤልኤምኤም ይሆናል ማለት ነው። ጀነራላይዝድ ሊኒየር ሚክስድ ሞዴል። ጂኤልኤም ጀነራላይዝድ ሊኒየር ሞዴል ነበረች። ሚክስድ ትመጣለች እዚህ ጋር ማለት ሚክስድ። አሁን ሊኒየር ሞዴል ነው። ሊኒየር ሚክስድ ኢፌክት ሞዴል የተባለው ሊኒየር ሪግሬሽን ነው። ሊኒየር ሞዴል ነበረ። non-linear mixed effect model ይባላል, which can be obtained from a non-linear regression model by introducing random effect. And at the same time, survival analysis እንደዚሁ extended ይሆናል። reality model ይሆናል። reality model which can be obtained from survival models by introducing random effect. ስለዚህ እያንዳንዱ እስካሁን ያየነው ስታንዳርድ ሞዴል extended ይሆናል። መቼ? correlated data analysis እናደርግ። How? By introducing random effect. How are you going to introduce random effect? That we are going to see next. So for fixed effect እና mixed effect model ስንል ሞዴላችን ሁለት ነገሮችን ይዟል ማለት ነው። both random effect and fixed effect. So for fixed effect model, the random effect in the model represents the influence of each individual cluster on the repeated observation that is not captured by the observed covariate. So a mixed effect model can be named as multi-level or hierarchical model or mixed effect model ይባል ይችላል። የተለያዩ ስሞች ሊኖሩ ይችላሉ። እና mixed effectም ተባለ multi-levelም ተባለ hierarchicalም ተባለ ተመሳሳይ ነው። the same name. አንዳንድ መጽሐፍቶች mixed effect model ተብለው ይጻፋሉ። አንዳንዶቹ ደግሞ መልቲ ሌቭል ሞዴል ይባላል። ሌሎቹ ደግሞ ሃይራርኪካል ሊባሉ ይችላል። is the same. So in longitudinal studies, repeated observation from the subject are nested within the subject. In multi-center studies, observation from the center are nested within the center. So random effects are used to accommodate the heterogeneity in the data which may arise from subject or clustering effect or from spatial correlation. በዚህ የሚመጣውን ራንደም ኢፌክት በማስገባት ሞዴል እናደርገዋለን ማለት ነውና አሁን ወደ ሞዴሉን እንሂድ። እንዴት ነው ሞዴል የምናደርገው? how are we going to fit the model? So the model formulation for mixed effect can be defined as this one. ካስታወሳችሁ ክላሱን ስንጀምር let me take you እንድታስታውሱ እዚህ ጋር ልውሰዳችሁ ሞዴል ኤክስቴንሽን ያልኳችሁ ማለት ነው። ተመስገን አለህ? ደህና ነህ? ይሰማል? ድምፅህ ግን አይሰማም። እስኪ አሁን ተናገር። አሁን አይሰማም። ዳዊት ይሰማል? ተመስገን
ትንሽ ይሰማል። እስኪ እስኪ ተመስገን እስኪ አጠገባችን ስለሆነ ነው የምንሰማው
ነው እንዴ? በዛው ክላስ ውስጥ ኦልራይት ኦኬ። ሶ ምንድነው የመጀመሪያ ቻፕተር ኢኒሼት ለማድረግ ነው ያስገባሁት። ለዛ ነው እንያቸዋለን ብያቸዋለሁና ሚክስድ ኢፌክት ስንለው ራንደም ኢፌክት ኢንትሮዲዩስ እናደርጋለን ማለት ነውና ተመስገን የጠየቅኩም ራሱን ሲይዛቸው ነው። ምንድነው ምንድነው ራንደም ኢፌክት እንዴ ራሱን ሲነካካቸው ነው የጠራው። So let me go back. So ሞዴል ስትራክቸር አሁን ሞዴሉን በደንብ መረዳት አለብን። ሊኒየር ይሄ ይችኛዋ ከሌለች ZI ከሌለ ሊኒየር ሪግሬሽን ነው። yi is equals to xi beta plus eij ከሆነ is linear regression አይደል እንዴ? አይደል ዳዊት? ረመዳን አለ ጠፍቷል።
አዎ አለ እየሰማ
all right so if we remove zibi it's just simply linear regression ነው የሚሆነው። ምክንያቱም xib ማለት x stands for fixed effect ኮቨሬቶች ናቸው። ቤታ ደግሞ ኮኤፊሽንት ነው። ኢአይ ደግሞ ረዚጁዋል ኤረር ተርም ናት። ረዚጁዋል ኤረር ናት። ረዚጁዋል ሜዠርመንት ኤረር ትሏት ትችላላችሁ። ስለዚህ አሁን ይሄን ሞዴል እስካሁን ከምናውቀው የሚለየው ይሄ በመኖሩ ነው ZIBI። ስለዚህ ZIBI ምን ይባላል? ራንደም ኢፌክት ይባላል። ራንደም ኢፌክት ይባላል። ይሄኛው ደግሞ XIBI ደግሞ ፊክስድ ኢፌክት ይባላል። ፊክስድ ኢፌክት ይባላል። ስለዚህ ራንደም ኢፌክት እና ፊክስድ ኢፌክት ስላለው ለዛ ነው we call it mixed ኢፌክት የተባለ። ሚክስድ was random and fixed ኢፌክት ስላለው we call it ያለው ለዛ ነው። so ሞዴል ካራክተሪስቲክሱ ወይም ሞዴል ፊቸሩ ምን ይመስላል? አሁን ይሄ እንዳያችሁት yi is the response variable, xi is fixed effect coefficient, fixed effect variables, beta is fixed effect coefficient, zi is random effect variable, or bi is the coefficient for the random effect. Zi is the random effect coefficient not bi. So AI is the residual. With that, BI is assumed to be normally distributed with the mean 0 and variance covariance matrix of D, and the residual is assumed to be normally distributed with 0 and variance covariance matrix of sigma. So B1 up to Bn and the measurement error are assumed to be independent. So beta is fixed effect, bi is random effect, the variance components are d and sigma. So the mixed effect model has three components: the fixed effect part, random effect part, and the residual or measurement error part. So a random effect model is a statistical model where the model parameters are random variable. It is a kind of hierarchical linear model which assumes that the data being analyzed are drawn from hierarchical data structure. So here model random intercept versus random slope ይኖረዋል። እዚች ጋር ብሬክ እናርግና
Hello.
Okay, I'm coming.
Okay. Okay.
እሺ ጥያቄ ነው?
አይ እዚህ ጋር ስለተቋረጠ ነው።
ብሬክ እናድርግ ብዬ ነው። ልክ 5 ሰዓት ላይ እንገናኛለን።
ኦኬ እሺ።
እዚህ ጋር ብሬክ እናድርግና
ኦኬ እሺ።
እስኪ እናንተም ቡናዋንም ሻያንም ብላችሁ ኑና
እሺ።
ክፍያውን በሪሲፕት ልኩልኛላችሁ እከፍላለሁ።
እናመሰግናለን። ያንተ ምን እስከተናገር እስከታም የተናገር እስኪ ታሜ እስኪ ቼክ አድርጎ እና ታሜና እስኪ ዴቭ
So there are 3 lines here. The first one is the one at beta naught plus ui, where beta naught is fixed slope, fixed intercept, ui is random intercept. The third one is at beta naught, which is a fixed intercept plus ui naught random intercept. So here the 3 lines vary by its intercept, random intercept and random intercept plus fixed intercept. So the middle one, the blue one, is the average plot, average line, the average regression line. So this average regression line has an equation of mu is equals to beta naught plus beta 1 x, where beta naught is fixed intercept, beta 1 is fixed slope. Beta naught is intercept, beta 1 is slope. So when you add random intercept and random slope, the models will be either this one or this one. ይሄኛው fixed ላይናችሁ ነው without random effect, whereas the 2 lines indicate with random intercept and random slope. ስለዚህ እዚህ ጋር ይሄኛው ለምሳሌ የዚህኛው ላይን የመጀመሪያው ላይን እንደምታዩት this line stands for mu is equals to beta naught, this one is random intercept plus beta 1, this one is random slope. So when you add random slope and random intercept, then the model will be deviated from the fixed effect regression model. So u naught 1, that's random intercept, u11 is random slope. ስለዚህ ሞዴሉን ፊት ስናደርግ ሞዴላችን ራንደም ኢንተርሴፕት ሊሆን ይችላል ወይም ደግሞ ራንደም ኢንተርሴፕት ኤንድ ራንደም ስሎፕ ሊሆን ይችላል ወይም ደግሞ ራንደም ስሎፕ ሞዴል ብቻ ሊኖረን ይችላል ማለት ነው። Okay. So the other one is other concept in multi-level or mixed effect model is correlation structure. When you say correlation structure, it means the type of correlation the data experiences or the data has. There are different correlation. ቀደም ምን ብለናል? ዴታው ኮሪሌትድ ነው ብለናል። ስለዚህ ኮሪሌሽን ደግሞ አንድ አይነት ኮሪሌሽን አይደለም ያለን። ዴታችን የተለያየ የኮሪሌሽን ታይፕ ሊኖረው ይችላል። That's what we call it correlation structure or correlation type. The correlation type might be independent correlation structure ነው ካለ the observations are independent, there is no correlation ማለት ነው። ይታያችሁት አሁን this is a correlation matrix. So the diagonal is 1 1 1, the off diagonal is 0. 0 means when the correlation is 0, it means the observations are independent ማለት ነው። ስለዚህ independent observation ከሆነ correlation ማትሪክሱ 0 off diagonal ይኖረዋል። the other exchangeable ይባላል። exchangeable correlation structure ማለት ደግሞ here is the type. The off diagonal is always the same, አንድ ነው የሚሆነው correlation and observation ከራሱን ከራሱ ኮሪሌት ስናደርገው አንድ ነው የሚኖረው። So of diagonal is row, which is common for every of diagonal of every cell. Row now in the so row is a correlation. So if the observations Yij and Yik, if the correlation between two observations is equal to row, where J is different from K, that type of correlation structure is known as exchangeable. The third one is autoregressive. Autoregressive order one. So for autoregressive, if the correlation of the two observations is equal to rho raised to Tij minus Tik, then this type of correlation is known as autoregressive. And the last one is unstructured.
Sorry.
Okay.
Sorry once, Professor.
Uh-huh.
ኮሬሌሽን ስትራክቸር ይቆራረጥ ነበር። አሁን አሪፍ ነው። ከስትራክቸሩ ብንጀምር።
Okay. So what I said was
ኮሬሌሽን ስትራክቸር ፓርቱ ጀምሮ ይቆራረጥ ነበረ።
okay. How about now?
አሁን it's well.
All right. So when we say correlation structure, it means the type of correlation the data experience or the data behaves. So there might be different correlation among the data or among within the data among the observation. If you randomly pick two observation, y at time s and y at time t, if the correlation of these two observations is equal to 0, that means there is no correlation, independent correlation structure. Whereas if you pick two observations, Yij and Yik at different time point, and this correlation is equal to rho, then this type of correlation structure is known as exchangeable. Whereas autoregressive የምንለው ደግሞ እነዚህ ሁለቱም ኦብዘርቬሽኖች ኮሪሌሽናቸው በታይም ዲፔንድ የሚሆን ከሆነ autoregressive order 1 እና order 2 የሚባል የተለያየ ኦርደር ሊኖረው ይችላል። The last one is unstructured. Unstructured የምንለው ደግሞ if you pick two observations in the data and the correlation of these two observations in that data in the same data set is equals to rho jk, which means different at different time point. This kind of correlation structure is known as unstructured. Unstructured የምንለው correlation structure እንደዚህ የተለያየ ከሆነ ለምሳሌ በሜዠርመንት 1 እና በሜዠርመንት 2 መካከል ያለው correlation ይሄ ይሆናል። በ1 እና በ3 ይሄ፣ በ1 እና በ4 ይሄ. So at each time point the correlations are different የምንል ከሆነ that type of correlation is unstructured. So in general በጣም commonly የምንጠቀምባቸው correlation structures እነዚህ አራቱ ናቸው: independent, exchangeable, autoregressive, and unstructured. But there are also other type of correlation structure which were not commonly used in the modeling. Let us see the example. A trial was conducted to test if the new drug is effective. A total of 200 patients were randomly assigned to two arms. ይቆራረጣል እንዴ?
አሁንም እንቆራረጣል።
ምን ነው ሻይ ብሬክ ስታደርጉ ችግር ተፈጠረ እንዴ?
ኮሪሌሽን ስትራክቸር ከሱ ጀምሮ አውቶግሬቲቭ እና አንስትራክቸር
እንዳውም እኮ መቆራረጡ ይቀንሳል ብዬ ነው ብሬክ ያሰጣችሁ የነበረው።
ኦኬ
የእናንተ ኔትወርክ ማለት የራሳችሁ ኔትወርክ ማለት ነው። with the ያለው ኔትወርክ
ጭራሽ ጠፋ እንዴ?
እነዚህ
ነው ኮሪሌሽንስ ከዚህ አሪፍ ኤክስቼንጅ አሁን ከዚህ ሄሎ
አሁን ይሰማል?
አሁንም ወዳው ሌሎች ጋር ምንም አይሰማም እንደውም እንትን
ኦኬ እስቲ ቆይ ምናልባት ከኔ ጋር ከሆነ አንድ የሆነ
አይሰማችሁም?
Aunus. Hello. Hello. Aunus someone? Aunus someone?
ይቆራረጣል እንጂ
አሁን እንጂ about how about now?
አሁን እስቲ
አሁን ይቆራረጣል?
አሁንስ now it's well አይደለ መጣለት ይቆራረጣል
ይቆራረጣል
አንዳንድ ጋር አይደርስም
ይቆራረጣል
ይደርሳል
ኦኬ
ኖ ፕሮፌሰር ይቆራረጣል
ኦኬ እስኪ አሁን ይሰማል አሁን ሄሎ 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 how about now
hello
how about now
hello
ይሰማል okay
still አይሰማም
all right
ምንም የለም የሆነ ነገር እኮ የሆነ እንትን ነገር የለም ኦኬ በቃ የለም ማለት
አሁን ይሰማል
አይሰማም
ኦኬ I hope አሁን የሚሰማ ይመስለኛል አሁንስ hello 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 hello
አቤት
አሁንስ
አቤት ሄሎ ይቆራረጣል ሄሎ ሄሎ
ይሰማል አሁን
ሄሎ በጣም ሞታ ምናምን ነገር
ኦኬ ሄሎ
አቤት ሄሎ
አሁንስ ይሰማል
ኦኬ ያው ተመሳሳይ ነው በጣም እየተቆራረጠ ነው
ኦኬ እንዳውም ኔትወርክ አሁን የተሻለ ነው ከዚህ ከኛ የተሻለ ኔትወርክ ነው ያለው እሺ
ኦኬ
ኦኬ ረመዳን አለህ ሄሎ ረመዳን
አቤት
ሸራ ያንተን ስክሪን ሸር አድርግ እስኪ
ረመዳን እስኪ አቤት
Hello, could you hear me, Professor? I hear nothing.
Can you share your screen? Share your screen. Can you share your screen?
Share screen.
Okay. Yes. Yes.
Okay, no. So now you can present task 1. Can you present task 1?
Hello.
Task 1.
Okay. Okay. Here is my task 1. I have reviewed five literatures. And the first one was macrosomic births in Abuja, a case control study of predisposing factors and the early neonatal outcome. The outcome variable was macrosomia and neonatal complications. The statistical methods used were logistic regression. Yes, because the outcome variable is categorical and a logistic regression is appropriate. The second was predictors of edema among children hospitalized with severe acute malnutrition in Jimma University Hospital, Ethiopia, a cross-sectional history. The outcome variable is predictors of edema. The statistical methods used was chi-square, Fisher's exact test, and the student t-test were used to test for differences in proportion or mean between groups. Simple and multiple logistic regression were employed to identify predictors of edema. And the risk ratio with 95 confidence interval was reported. Multiple logistic regression were employed to identify predictors of edema. The question is the model appropriate for the outcome variable? Yes, the presence and absence of edema is a categorical variable. So the researcher is using simple and multiple logistic regression to identify predictors of edema, chi-square Fisher exact test, and student t-test. The third one was risk factors associated with breast cancer among women in Addis Ababa, Ethiopia, and matched case control study. So the outcome variable was breast cancer. The statistical methods used were descriptive statistics, including frequencies and proportions were employed, and multivariable logistic regression was used to measure the association between covariates and outcome variables. Is the model appropriate for the outcome variable was the question. So yes, the model is appropriate because the dependent variable is categorical with many predictor variables. The fourth one is treatment outcome and associated factors in hospitalized children with severe acute malnutrition, a prospective cohort study. The outcome variable was nutritional recovery, was diagnosed as dependent outcome variable. So Pearson chi-square test was used to see an association between categorical variables, while the independent two-sample t-test was used to compare means. Treatment outcome were categorized into censored and recovery, and nutritional recovery was considered as a dependent outcome variable. Kaplan-Meier survival analysis, life table analysis, and log-rank tests were used to determine the rate of nutritional status, recovery over time to estimate proportion surviving within each interval, and to compare time to recovery respectively. Bivariate and multivariate regression analysis were used to identify predictors of treatment outcomes. So it was nutritional recovery or cure, and statistical significance was determined using p-values. And the models used were appropriate because of the study combined different models like survival analysis, if there is time to an event, Pearson chi-square test used to see an association between categorical variables. So the fifth one and the last one is risk factors for viral hepatitis A infection in Gamhaha district, Sri Lanka, in unmatched case control study. So the outcome variable was the presence of viral hepatitis A. So the statistical model used was probable risk factors were determined by variant analysis, and the multiple logistic regression was used or performed in order to identify independent risk factors. The model was appropriate because the outcome variable is categorical with more than 2 predictor variables. That's why it is appropriate. I have finished the first task one, which was looking at the 5 articles.
Okay. Can you hear me now?
Now, yes, I can hear you, Professor.
So you can go to the task two.
Okay. On task 2, here is my Excel sheet, which I have prepared 100. This is the 100 with age, sex, age, weight, height, and marital status, family size, income. This is my Excel and the ID number up to 1 up to 100. So I will just move to the starter. Now I will go to file and import my Excel file. Since the sheet was prepared in Excel sheet, and then I will use and go to the, so it was this one, hypothetical data task 2. I have written this one. So I will import it. So there are here, it shows worksheet. I have only one worksheet and no need to go to other sheets. And now I have to click import first row as a variable to avoid that it to consider these variables as an observation, and then go to OK. And here, this is the variables which is seen around. Here are my variables, and now let me go to my do file, and so here is task to do file, and I will open it. It says blank. I have saved it. It is also available here.
All right. Okay. Okay, Ramadan.
Okay, bro.
What version of Stata do you have?
I have 16 version, and last night it said it couldn't open. It needs license or something. It was saying.
Okay, so MP, I think your that's why the version is different. That's why it comes like this. Anyhow, you can now stop sharing. Click stop sharing.
Okay, thank you, Professor.
Okay, I hope everyone now hear my sound, my voice, right? Is that okay?
Yes, now it is better.
So I was talking about the examples. Trial was conducted to test if the new drug is effective. A total of 200 patients were randomly assigned to 2 arms, old versus new drug, and followed for 12 months. And measurements were taken every 2 months, every month. The second example is the study aims to assess the impact of school type, public versus private, as well as student gender on student level math achievement score. The scores are measured once for the students in the school. The last one, the third one, is researchers are studying the effect of 2 different treatments on nucleotide bonding in 3 regions of the brain in rats. Measurements are taken from the same 3 regions of the brain of each rat after each of the 2 different treatments. And this 3 example indicates 3 types of 3 sources of correlation. The first one is longitudinal, second one is cluster, third one is repeated measure. So in all examples, data are often hierarchical in nature, and we should not ignore this hierarchy. Using single level OLS, JLab analysis leads to unit of analysis problem or aggregation bias. Results incorrectly estimated precision or standard error, and ultimately results in incorrect p-value and incorrect conclusion. So the ultimate objective is we have to use multi-level model or mixed effect model to resolve all those problems. Let us start with example. Example 1, infant growth data. Follow-up study of newborn infant in Southwest Ethiopia. So wide range of data were collected on the following characteristics: basic demographic information, feeding practice, anthropometric measurement. Infants were followed during 12 months. Measurements were taken at 7 time points every 2 months from each child. So weight was one of the variables recorded at each visit. Now, the research question is, how does weight change over time? This is one of the examples that we are going to use in the next.
Hello, Professor.
Yes. Hi, Samam. Hello.
Still it has full.
ችግር አለ አሁንም?
አዎ እንደ መጀመሪያ ነው። ትራክ ነገር አለ።
ኦኬ።
በመሀል አሪፍ ሆኖ ነበር ረመዳን ፕሬዘንት ካረገ በኋላ።
ኦኬ ኦልራይት might be the time. Okay. ስላይዱ ይታያችኋል አይደል? ስላይዱ ይታያል።
ስላይድ ይታየናል። ኤግዛምፕል 1 ኢንፋንት ግሮዝ ዳታ።
አዎ እሱን እያያየ እንሂድና ዴታ ስትራክቸር ነው እዚህ ጋር ያቀረብኳላችሁ ያለው። this is the data structure. So the data structure looks like this. I don't know what the problem is. ወይም እስኪ አንዴ ልትሰውና እንደገና ልግባላችሁ መሰለኝ። I'm going to close and then I will join you again. I will rejoin you again.
Okay. Okay.